At this open-cast coal mine in China, you can descend for 500 meters through layer upon layer of rock representing tens of millions of years. Right at the bottom lies a layer of what was once wood and leaves and is now coal and shale. It's an ideal place for Professor Bob Spicer to study the plants that influenced the climate all that time ago.
These leaves last saw the light of day some 50 million years ago when they were on the trees, taking in carbon dioxide and using the energy of the sun to fix that carbon into their tissues, leaves and twigs and the like. Now the original leaves had a cooling effect on the atmosphere because they were taking carbon dioxide out. And when we burn the coal and the carbon, oh that's a nice one, and put it back into the atmosphere today, we have the opposite effect. We warm up the atmosphere.
Now all the coal is being carried up to the surface to be burned in the power station which provides electricity for hundreds of thousands of people. Oil and gas, like coal, are also fossil fuels. When such fuels are burned, the carbon recombines with oxygen and is released back into the atmosphere as carbon dioxide. The carbon dioxide spreads evenly through the Earth's atmosphere, thickening the greenhouse blanket that wraps the world and further warming the planet. The first regular measurements were started 48 years ago from the top of the extinct volcano of Mauna Loa in Hawaii. And it is the rate at which the carbon dioxide blanket is thickening that is causing so much concern. When I was a boy in the 1930s, the carbon dioxide blanket was still below 300 parts per million. This year, the thickness reached 382, the highest figure for hundreds of thousands of years. Every year, the blanket is getting thicker. But how can we possibly know that carbon dioxide levels are higher now than they were thousands of years ago?